Electronic materials from physics of engineering for same. So the electronic materials of the topic contain the note. First of all, the note I'm giving you are totally exam based, so please try to write these all note. So the first topic of electronic material was the free electron of theory. Okay, let me write. Please try to write with me. These notes are totally exam based, so okay. Free electron theory. The purpose of free electron theory was to explain the electrical, thermal and magnetic properties of the metal. So let me write. It explains the thermal, electrical, magnetic properties of metal. So this topic is not so long, so free electron theory stops here. Okay, it explains the thermal, electrical and magnetic properties of metal. So that's much from free electron theory. Now I'm going to tell you about the classical theory of free electron. Okay, I'm going to teach you about the classical free electron theory. That was the important theory. The many of the theories come from here, so it is important. Please note down. Classical, theory theory of, let me read this, theory of free electron. Okay, free electron. Okay, this theory was proposed by Drude and Lorentz in 1900 AD. This classical theory of free electron was proposed by Drude and Lorentz in 1900 AD. According to this property, the metal containing the free electron obey the law of classical mechanics. Okay, that's much from this topic. Let me write and please revise this topic. So okay, let me write in. Proposed by Drude and Lorentz in 1900 AD. Okay, like statement of this theory was like this. According to this theory, metal containing free electron follows the law of classical mechanics. Law of classical mechanics. Okay, that's much from the classical theory of free electron, which was proposed by Drude and Lorentz in 1980. This theory tells that the metal containing free electron follow the law of classical mechanics. Okay, let me silent my phone. Okay, and now that another topic is that about this classical theory of free electron. Classical theory of free electron also have the many assumptions. Like these assumptions are so much totally important for examination. So let me write about this assumption and let me explain you about them. Okay, it's time for assumption of classical free electron theory. Okay, the first assumption, let me choose red color. After the red color, the first assumption of this theory was that another topic. First, let me draw the star, which was very interesting, so I forget to draw. Okay, no, no. Okay, I finally learned to draw the star as a point. Let me draw. Okay. Oh, sorry for the disturbance to draw the star. Okay, the valence electron of atom are free to move above the whole volume of matter. This theory, this is the first assumption of the classical free electron theory. The valence electron of atom are free to move about the whole volume of a metal. It tells that the valence electron the atom have in their outermost orbit are free to move above the whole volume of the metal. Okay, let me write this also. Please try to write with me. I am telling you time. Okay, let's go to the next assumption. These assumptions are not so much hard, so I'm explaining while writing. Okay, the next assumption was the free electron move in the random direction and collide with either positive ion fixed with the lattice or other free electron, and the collision which is done was elastic and there is no loss of energy. Energy is conserved in this method. So the free electron move in the random direction. You also know the free electron are ready to combine with another electron, so they move in random direction and collide with either positive ion that is fixed with the lattice. They either collide with the positive ion that is fixed with the lattice or other free electron. So the collision is also the elastic in nature. Collision is elastic in nature means like the elasticity means like the rubber, okay, there is no loss of energy. Energy is conserved in this method. Okay, let me write. The free electron moving in random direction with collide with either positive ion fixed with the lattice or if they do not find the positive ion fixed with the lattice, they will collide with the other free electron. Okay, another point, the collision was elastic. I already told you that. Elastic, if it was elastic, then the energy is also conserved. Means the energy was not lost. Okay, this was the two assumptions of classical free electron theory. I'm also going to teach you three more assumptions. Let me scroll down. Please first of all take the screenshot of how we did it. Okay, I know some of you are lazy, so you are not going to write with me. Okay, let me write the assumption. Another assumption was so totally easy, that the momentum of free electron theory, the law of classical kinetic energy. This was classical kinetic theory. Okay, you know that the momentum of the free electron theory, the momentum which the free electron have, this theory obey the law of classical kinetic theory. Yes, must let me write. Please remember these are point. This point is so small. The momentum of free electron theory obey the law. The momentum of free electron theory obey the law of classical kinetic theory. Okay. Another point was is also small based on the topic, that the velocity of electron in metal, like, okay, the velocity of electron in metal obey the classical Maxwell-Boltzmann distribution of velocity. The velocity of electron, or the electron velocity, in the metal, the velocity of electron in the metal obey the Maxwell-Boltzmann distribution law, or the theory of velocity. Boltzmann has proposed his theory about the velocity of the electron. So the electron velocity in metal also obey the classical Maxwell-Boltzmann distribution of velocities. Let me write. Please don't try to write with me. So everything in this topic about the electron are in the form of like the electron in metal. Okay, the velocity of electron in metal follows classical Boltzmann, classical Maxwell-Boltzmann. There's not Boltzmann, this is Maxwell-Boltzmann. Okay, Maxwell this opposite. Distribution of energy. Okay, these are I have written almost to the 4th point, and the last point was just like that. When we apply the electric field to the metal, the electron in the metal are accelerated. When you apply the electric field in the metal, the electron of the metal are accelerated, but they are accelerated in the opposite direction of the applied field, electric field. Okay, I'm writing down. When we apply electric field in the metal, the electrons in metal are accelerated. They are accelerated, but they are okay. Metals are accelerated in the direction, but the direction is opposite to the applied electric field. Direction which is opposite to the applied electric field. Okay guys, I have almost completed the assumption of classical theory. Let me revise you about all this topic. Free electron theory, which explain the thermal, electrical and magnetic properties of the metal. Okay, free electron theory explain the thermal, electrical and magnetic properties of metal. That's much from free electron theory. And there is the type about the classical free electron theory, which was proposed by Drude and Lorentz in 1980. And I have mute the call. And which was proposed by Drude and Lorentz in 1980. According to this theory, classical theory of free electron, according to this theory, metal containing the free electron follow the law of classical mechanics. Okay, follow the law of classical mechanics. Let me smooth the pen. Okay, then we are going to learn about the assumption of classical free electron theory. The first assumption was that the valence electron in the atom are free to move about the whole volume of metal. The valence electron of atom, the atom in the outermost orbit. Okay, the valence electron of atom are free to move about the whole volume of metal. And the free electron move in random direction and collide with either positive ion fixed with the lattice. The free electron move in random direction, not collide. They move in random direction. When moving in random direction, they collide with either positive ion. The positive ion that is fixed with the lattice. If they do not collide with the positive ion fixed with the lattice, and they will collide with the free electron. Okay, The collision was elastic. Please, student, concentrate here. The collision was less elastic. The energy was not lost. I.e., energy was conserved, we can say. The moment of free electron theory obey the law of classical kinetic theory. The momentum of free electron theory. The momentum of free electron theory obey the law of classical kinetic theory. The velocity of electron in metal. Another point, the velocity of electron in matter. The value follow the classical Maxwell Boltzmann distribution of energy. Okay, that's simple. Classical Maxwell Boltzmann distribution of energy. Okay, another point was when we apply the electric field in the metal. Okay, when we apply the electric field in the metal, the electron. Okay, when we apply the electric field in the metal, at the time when we apply electric field in the metal, the metal was made of a various electrons. So the electron in the metal are accelerated in the direction which is opposite to the applied electric field. They are accelerated in the direction which is opposite to the applied magnetic field strength. Okay, that's much about the free electron theory, classical theory of free electron, and the assumption of free electron theory. Okay, after that I will teach you about some of the electrical conductivity as for electron theory. So stay tuned, guys. Okay, bye bye, see you next time. Please revise all the topics.